let's get going on example 10. So example 10 is basically the same kind of problem as example 9. Okay, we just have a fraction to deal with in our function. So if you feel like you understood how to do example 9 and you want to go ahead and try to do example 10 on your own, go ahead and pause the video and fast forward to the end and see if you get it right when you get done. Alright, so the first step, we are dealing with our exponential graph, and the first thing we do is determine if this thing is a growth or a decay. Okay, which we look at the base to determine that, our C value. Okay, which this is our C. Alright, so our C value is a fraction, which means this will be a decay. So that means when we graph it, we already know that from left to right, the graph should decrease since it is a decay problem instead of a growth problem. Alright, so for our 3 points that we'll be graphing, okay, at -1, remember this is when we find the reciprocal of the C value, so we flip the C value. So our C value is 1/4, so if I flip that, it would be 4/1, which is simply a 4. Okay, the point 0, 1 is going to stay the same. And then at 1, our C value is going to be 1/4. Alright, now before we plot these points, we know that our asymptote equation, whenever we have an exponential for now, okay, will always be the x-axis, which the x-axis is the line y equals 0. Okay, so that will be my asymptote equation. Alright, so I'm going to draw that in first so I know I cannot cross that line when we plot our points. Okay, so I'm going to draw in the line y equals 0 first. Alright, so our graph cannot cross y equals 0. So we have a point at -1/4. We have a point at 0, 1. And we have a point at 1, 1/4. So when you do that, you just approximate, just go a little bit above 0. Alright guys, when we draw this, we're going to get really close to the x-axis, but we will not touch it. We will not touch it. Alright, and then this one's just going to continue on. Look at that graph. It's awesome. It's awesome. Alright, so for our domain and range, okay, it's always the same when we do these problems for now. So domain, we ask ourselves, how far left does our graph go? Okay, so when we ask ourselves how far left does the graph go, okay, that's when we want to know how far left it goes, which, even though it doesn't look like it, I promise you this graph will continue to get wider and wider, so it will head in the negative infinity direction on our x-axis. Better watch out, that's where the demon cats hang out. Alright, and then we ask ourselves, how far right does the graph go? So we ask ourselves, how far right does it go? Okay, which if you notice, our arrow is headed in the positive right direction. It's headed that way for forever. So that would be to infinity and beyond with Buzz Lightyear. So that would be our interval notation and our inequality notation. Since we go from negative infinity to positive infinity, we are spanning all the x values. So our domain would be x is all real numbers. Alright guys, our domain, again, it's been the same this whole time, so this should kind of be a refresher. So for the range, we asked ourselves, how low does the graph go first? So, when we look here, how low does it go? Well, guess what? It goes down really close to 0 on the y-axis, but it cannot cross 0 because of our asymptote. Okay, so that's when we have to put our 0 in a parenthesis because it cannot equal 0. Alright, then you ask yourself, how high does the graph go? Alright, and if you see here, that arrow right here is pointing up. So it's headed in the positive y direction for forever. So this would go to positive infinity on the y-axis. Alright, then for our range, remember range always involves the y, so we'll start with the y. And then you ask yourself, are these numbers, we know we're dealing with 0, so there's a 0 in our answer. Are these numbers larger or smaller than 0? Well, these are things like 1, 2, and 3. So they are larger than 0, but we cannot equal 0, so we're just going to say y is greater than 0. Alright, so that's the domain and range, and that is our lovely exponential. Alright, so now we are moving on to our logarithm graph, which is the inverse of our exponential graph. So we'll be applying those inverse properties from the previous section. Okay, so the first thing it asks us to do is convert the exponential equation into a logarithm equation. So I'm going to start by writing our exponential equation, which it was f of x equals 1/4 to the x power. Okay, remember whenever we are converting this into an exponential or into an inverse equation, the first thing we want to do is change f of x to a y. So it makes things a little easier. Alright, so after we change our f of x to a y, the first thing we do, we have to interchange our y and our x. Okay, so that's when the x hops over to the y and the y hops over to the x. So my x is going to be where this y is right here. I'll go up here. So x equals 1/4, and then now my x will become a y, like so. Okay, so we have interchanged our x and our y value, and now all we have to do is solve this bad boy for y, which the way we get y out of our exponent is to convert this into a logarithm. Okay, so when we do this, the base always stays on the same side, and it's going to stay with the log. So the base of our exponential is a 1/4, so that will be the base of my log. Okay, and then remember, these two are going to trade spots. So my y is going to hop to the other side of my equal sign, and the x will hop to the other side. So bam! This is my logarithm equation. We have solved this thing for y. Okay? Alright, so for our 3 points, we could sit here and look at the base and get our points, or since we already have our points for our exponential and these are inverses, all we have to do is interchange the x and the y values. Okay, so my first point was -1/4, so now it will turn into a 4, -1. My next point was a 0, 1, but now it will turn into a 1, 0. Holy hot dog. My previous point was a 1, 1/4, but now it will change into a 1/4, 1. Voila. So we're about to plot these points now. Remember in the previous problem for our asymptote equation, not only do our points interchange, but also our asymptote equation will also interchange. So it was the x-axis, so we're going to interchange this and make our x turn into a y. So our asymptote equation is now going to be the y-axis, which that is the equation x equals 0. Or you can think about just changing this y to an x, because we are interchanging. Okay, so it will be x equals 0 will be our equation. Okay, so I'm going to graph my asymptote equation first on the y-axis so I don't forget about it, where we cannot cross this imaginary asymptote. Alrighty, so my first point is at 4, -1, so I'm going to graph that first. So we're at 4, -1. My next point is at 1, 0, so that will be my next point. Bam! Alright, and then my final point is going to be at 1/4, 1. So I'm just going to go out a smidge on the x to about 1/4, and then go up 1. So this graph's going to look kind of weird, but this is what it looks like. It's going to kind of look like an L. It's going to kind of look like it's a little bit lower than the exponential graph. And then, curved it too much. Okay, and then it's going to get really close to the y-axis, but it will not touch. Alright, so this is kind of the shape of our graph right here. Alright guys, so that would be our logarithm graph. Alright, now for our domain and range, remember also when we have inverse functions, not only do the points and the equations interchange, also remember our domain and range interchange. So I don't even have to analyze the graph, I can just flip-flop my domain to my range to my domain. So the domain of my original graph was from -infinity to +infinity. So that is going to become the range of my new graph. Okay, so my range is now going to go from -infinity to +infinity. Okay, which in interval notation, since we're dealing with the range, okay, instead of it being x is all real, range is a y, it deals with the y, so it will be y is all real. Okay? Alright, and then the range is going to become my domain. So my range was from 0 to positive infinity, so guess what? My domain will also be from 0 to positive infinity. Say what? Okay, and then it was y is greater than 0 for my range. So for my domain, since domain is x, it will now be x is greater than 0. Okay, which if we look at the graph, it makes sense because so our domain says from 0 to infinity on the x. Okay, if you see on the x-axis, it gets really close to 0, but remember, it can't cross that line. It cannot. Okay, so it goes from 0, and then this arrow is pointing to the right for forever. So go to positive infinity. And then when you ask yourself, how high does the graph go? Okay, well, it goes up for forever. And then when you ask yourself, how low does it go? Well, it doesn't look like it, but it will gradually keep going down for forever. So it will go from positive infinity to negative infinity, which is all real numbers. Awesome. Alright guys, and our last step, remember, inverse functions are always symmetrical to the line y equals x, which, if you forgot what that line looks like, I'll make those points again. So this is for the line y equals x. So remember, this is the line where all of our x's equal our y values. So if x is negative 1, y is negative 1. If x is 0, y is 0. If x is 1, y is 1. Okay, so I'm going to plot these points, and the graph should be symmetrical to this line. So my first point's at negative 1, negative 1. My next point is at 0, 0. Alright, and my last point is at 1, 1. Alright, so let's see if we did it right. Should be symmetrical to this line. Alright, so this is the line y equals x. And if you guys visualize, if you were to fold this paper on that diagonal, okay, the graphs would be right on top of each other. Isn't that awesome? Alright guys, we're officially done with this section. So go ahead and stop the video and you can begin the next section. Awesome job, you guys.